Lesson 1.3 is brought to you by Lego Batman. Isn't he great? Okay, so in this lesson, it says identify and understand your learning style, but there really is no scientific based evidence for this idea of bodily, kinesthetic, interpersonal, intrapersonal, logical, mathematical styles of learning. So I'm going to skip all that. Plus, we're not in class where we can take these surveys together. And we're really, our goal is just to look at bar graphs and make sure we're able to read them and how to create them and then compare them to pie graphs. So we're skipping this learning style stuff, and we're going to jump right into what is a bar graph. Well, here's a picture of a bar graph. It's a visual representation that has values corresponding to categories, and bar graphs specifically use categorical data. If you take 133, our stats course, this is also called quantitative data. Let me try again, qualitative data. And this type of data is data that is not numerical in nature, or the numbers, the numericalness of the numbers have no meaning. For example, social security number is a categorical data value because your social security number is simply your name, like your legal name for the United States government. So here's an example of the average daily reach for the top 5 websites in the world. So we've got Google has a reach that's almost 50%. We've got Facebook that's got a reach slightly over 40%, YouTube, et cetera, et cetera. So note that this is a pretty bad bar graph because we don't know the actual values of these percentages. We just have a rough idea, and we have to estimate it based on the lines. Question 3 just says, which site has the highest daily reach? Well, that's clearly Google. And what percent of users go to that site on an average day? So it looks like, let's say 49% is my rough estimate. You might call that 49.5, you might call that 48. It's just slightly below 50. Notice what we mean by reach here, I believe, is when you log in, this percentage of users actually go to this website for that day. Okay, so which is higher, Google's daily reach or the combined daily reach for YouTube and Yahoo? Well, here's YouTube, here's Yahoo. Let's call Yahoo like, I don't know, 25%, maybe that's a little high. Let's call YouTube 32%. So if we add those two percentages together, we get what, 57%, and that looks like more than Google, right? Because we claim Google is roughly 49%. The other way we could do this is measure each of these and then see, is the sum of these two measurements longer than that one? And that would be a really conclusive way to tell. By the way, the explanation of our answer here is this calculation. And we're going to say YouTube, oh, excuse me, that YouTube, that T has to be capitalized, / Yahoo is higher. All right, so our author said he did some poking around and found that on an average day, about 690 million people visit Facebook. And then based on Facebook's daily reach, how many people access the internet each day? All right, so Facebook looks like, let's call Facebook's daily reach 41%. So remember what we're meaning by this. We're saying that 41% of all people that get on the internet each day go to Facebook. So we're told that 41% of all internet users, we'll just say internet users, gets on Facebook, or that 41% of all internet users go to Facebook, and that number is 690 million people. Well, if you recall back from lesson 1.1, when we have a percentage, an unknown total, but we know what that percentage is from the total, we just have to solve this nice little equation. So I'm going to divide both sides by 0.41, and this will give us the total number of internet users around the world, or at least an estimate for it. So let's switch to Desmos real quick, and we'll do 690 million. Now, some of you may be wondering, why isn't he putting in all of the zeros for 690 million? Well, the reason is I can just know that this number I'm writing down, 1682.926.82927, is in millions. All right, so let me show you what I wrote down here. So I wrote this down as millions, and millions, well, let me fill out this little thing as an aside. The words that are associated with numbers. So if I say hundreds, I think everyone's pretty familiar with that. Hundreds corresponds to 2 zeros. In other words, 100. Thousands corresponds to 3 zeros. In other words, multiply whatever the number is by 1,000 if you want to convert it to a number. We could say 10,000s, we could say 100,000s, etc., etc. So 10,000s is literally 10,000. So how many zeros is a million? Well, it's 6 zeros. In other words, what I want to do here, if I want to convert this number into its number without the words, I need to multiply this by 1 million. Well, that has the effect of moving the decimal 6 places to the right. 1, 2, 3, 4, 5, 6. So my number is 1,682,926,829, and then we can ignore this 0.27 because this is people. All right, so what is this number in words then? Well, let's go backwards. Here's hundreds, here's 100,000s, here's millions, here's 100 millions, here's billions. Let me try again. Is that right? No, that is right. So 1.6 billion people is what we're saying. So 1,682,926,829 users log on to the internet each day if we take into account that 41% of all people getting on the internet go to Facebook. Now, this guy said he also found that an estimated 3.3 billion people are internet users. That means each day, in reality, there's this many people on the internet. So why are these numbers so far off? I mean, we're only like 50% of the way there. In other words, what accounts for this discrepancy? Well, one big thing is Facebook is not available to all people around the world. For example, if you live in China, Facebook is not allowed. It is entirely blocked. And if you think about the population of China, that's almost 1.6 billion people. That accounts for about half of this. There's other places, North Korea, I'm sure Facebook is completely banned, blocked from all servers. So there's other places where people can't access Facebook. That would explain this big discrepancy. Okay, so we're skipping number 7 because we didn't collect that data, and we're skipping number 8 and number 9, and so we're going to go all the way to page 35, and we're going to look at a set of questions here, one last set of questions for this portion of the video. So this was an interactive poll. Notice we surveyed this many people. 2,094 people are included in this survey back in October 2012. And it was asking which former president a person would most enjoy having a burger with. And these are the top 4 vote getters. Notice this is not all of the votes all the people that were voted for, but these were the top 4. So which former president had the highest percentage? Well, that's President Clinton. And then, so how many of the respondents would most enjoy having a burger with the most popular choice? Notice the most popular choice is the person we identified here. So what we have to do is get a rough estimate of what is this percentage of respondents that said they would pick Clinton. I'm going to go ahead and say this is 22%. That's going to be my guess. You might think it's slightly different, totally fine. And as we've been doing in the last 2 units, we take that percentage, convert it to a decimal, and multiply it times the total number of respondents, and that will spit out how many people chose President Clinton. So here I go to Desmos, 0.22 times 2094, and there's our answer, 460.68 is the exact number. Unfortunately, you can't have 0.68 of a person, so we'll round using appropriate rounding rules. This would be 461 respondents. Okay, which two presidents tied in the poll? That would be Lincoln and Reagan. If you're feeling like these are really basic, straightforward questions, awesome. That means you're comfortable reading bar graphs. If you're like, man, this is a little bit of a struggle, no worries. Hopefully you're picking up um, how to read these bar graphs. Okay, so how many people chose a president not in the top four? Ooh, great question, right? So what we need to do is calculate what are the approximate percents of all these. Wait, which two presidents tied in the poll? And I said Lincoln and Reagan. No, that is totally wrong. It should be Reagan and Kennedy tied in the poll. They have the exact same bar graph. Clearly, I'm not very good at reading these. Okay, I'm going to call these two guys 14% apiece, and I'm going to call Lincoln 15%. So what we can do is find out how many total people were there, or what percentage of the votes are accounted for with these four gentlemen, these four presidents. So I'm going to add the 14s, the 14s, the 15s, and the 22s together. I'm going to add these two together. That's 28%. I'm going to add these two together. That's 37%. That makes it a little easier for me to add. Let's see, 7 plus 8 is 15. So 3 plus 2 is 5, plus 1 is 6. So 65% of the people have voted are considered with these four. So if I subtract that value from 100, that tells us how many didn't choose these top four. So 35% chose some other president. Remember, this was back in 2012. If you're wondering why some of the more recent presidents are absent, that would be the reason they weren't elected yet, maybe. Okay, so we just need to do 0.35 times 2094. Again, Desmos, one of my favorite calculators, although there are other great online free calculators out there. And we get 732.9. Again, when rounding, for the problems I give you, I often won't tell you what to round to because I want to see what you think about the data. For rounding, we should round this to 733, and these are respondents again. Of course, we should round to the nearest whole number because we're talking about people. You can't have part of a person. All right, last question on this page. So here we've got the net income or loss for Ford Motor Company from 2007 to 2011. So let's describe how Ford performed in 2008 and 2010 in terms of profit or loss. So in 2008, they lost $15 billion. Notice the units on these are in billions, which is given here. And then the year here is 2008, we got negative 15. So they lost negative $15 billion. I'll put lost here since it's negative. And then in 2010, they have a profit of $7 billion. I guess I should have said loss here and then profit here. Now what we could do is add up all of these years, add up all these numbers, and you can get to it right. Yeah, there we go. Add up all these numbers and determine, did they, over this 4-year span, were they profitable or did they lose money?